Welcome to The Explainer. We all know that magnets stick to the fridge, but have you ever really stopped to ask why? I don't just mean that they have a field, but what is physically, mechanically causing that pull? Well, today we're diving into a pretty radical theory that proposes a direct, mechanical answer to one of nature's most fundamental and, honestly, mysterious forces: magnetism. So, to really get to the bottom of this, we're going to start with the magnetic mystery itself. Then, we'll build a whole new picture of the universe, one that's just full of photons. From there, we'll see how that one single idea might just explain not only attraction, but also why magnets are so different from other objects, and even what it could all mean for huge concepts like antimatter and maybe even our own place in the universe. All right, let's set the stage. The core problem this theory is trying to solve is the fact that we don't really have a satisfying mechanical explanation for what magnetic force actually is. Look, we can describe the effects of magnetism with incredible precision, right? We have field lines, we have equations, they all work. But that doesn't answer the deeper question. What is the physical mechanism? What is actually happening between two magnets that makes them pull together through what we all think of as just empty space? And this quote right here, it gets to the very heart of this theory's premise. The argument being made in the source material is that mainstream physics is fantastic at describing what magnetism does, but it kind of stops short of explaining the actual physical cause of the force. It treats it as a field effect, but without a direct, mechanical cause. So to build a mechanical explanation, this theory starts by completely reimagining the universe itself. It proposes a new foundation for, well, everything, and it calls it the charge field. The idea here is pretty wild. Space isn't empty, not at all. It's filled with a constant universal sea of real, physical photons. And this isn't just some background noise. This charge field is proposed to be the actual engine of electromagnetism, acting through direct physical contact. So here's the crucial point. Forget spooky action at a distance. In this model, every force is a physical interaction. Electrons move because they're literally being bombarded and pushed by a current of photons, kind of like a log being carried down a river. All electromagnetic effects, every single one, traces back to this constant physical bombardment. Okay, so that brings up a pretty key question, right? If this single charged field is responsible for all electromagnetic stuff, how does it create two distinct forces that we know as electricity and magnetism? Well, the theory offers a really elegant distinction. It proposes that electricity is simply the result of these charged photons moving in a straight line, a direct, linear push. Magnetism, on the other hand, is the effect of the exact same photons, but spinning. So it's just one particle with two different types of motion, creating two completely different forces. Okay, so with the ideas of a photon field and photon spin in our toolkit, we can finally get back to our original question. How does magnetic attraction work on a mechanical level? First, we need this one last crucial concept from the model. Every single object is said to exist in a constant state of balance. So on one side, there's a constant outward push from the charge field's photon bombardment. But on the other, there's a constant inward pull from a force the theory defines as gravity, which is linked to universal expansion. So just imagine everything. You, me, this table is in a constant tug of war. So here it is, the big reveal. When the north pole of one magnet meets the south pole of another, their charge fields, which are spinning in opposite directions, they interact. Those opposing spins cancel each other out. And when that happens, it dramatically weakens the repulsive electromagnetic push between them. Now the background, attractive force, gravity, that hasn't changed at all, so it suddenly wins the tug of war and the magnets pull together. Let me put it this way. Attraction isn't really a pull at all. It's a reduction of a push. It's kind of like two gears spinning in opposite directions, meshing together perfectly. They just neutralize each other's force, which allows that other background force to take over. And of course, repulsion is the exact opposite. When two like poles, say two north poles, meet, their photon fields are spinning in the same direction. So instead of canceling, the spins stack on top of each other, basically doubling their repulsive force, and pushing the magnets apart with that strength you can really feel. This leads to a really obvious question, doesn't it? If all objects are surrounded by this charge field of spinning photons, why isn't everything a magnet?
The answer, according to this theory, comes down to a single word: coherence. In a normal object, like a piece of wood, the photon spins are totally random, a 50-50 mix of clockwise and counterclockwise. They just cancel each other out internally, which results in a balanced average repulsion. But in a magnet, the spins have all been aligned to be coherent. And this alignment is what allows for the dramatic effects we see: near total cancellation when opposite poles meet, or powerful stacking when like poles meet. It's really the difference between a disorganized crowd and a disciplined army.
So, we've defined magnetism, and we've talked about what makes magnets so different. But now let's zoom out, because this mechanical model of spin has some truly profound implications for other huge areas of physics.
And this is a big one. The theory proposes that antimatter isn't some strange, exotic substance from science fiction. It's simply normal matter whose fundamental particles just happen to have a reversed spin relative to their environment. It's a mechanical difference, not a mystical one.
And the theory proposes this reversal is surprisingly simple. Imagine a clock. From the front, its hands are moving clockwise. But if you could see right through to the back, you'd see them moving counterclockwise. A simple flip in perspective, or in this case, a physical flip of the particle itself, is all it takes to reverse its relative spin, causing it to behave just like an antiparticle.
And here's one last fascinating implication from the theory. Remember that cosmic tug-of-war we talked about between the repulsive electromagnetic field and the attractive gravity field? Well, the source proposes there's a specific scale where those two forces find a perfect equilibrium, and that scale is right around 1 meter.
This leads to a potential answer for a very, very profound question. Why are we the size we are? The theory suggests that life exists at this meter-ish scale because it's a point of maximum stability. We're not so small that we're constantly getting battered by particle-level forces, and we're not so large that we're dominated by the orbital mechanics of gravity. Our stable, human-scale world exists right at this amazing cosmic equilibrium point.
So we're left with a final thought here. This theory presents a universe that's driven by simple mechanical interactions: pushes, collisions, and spins. It suggests that magnetism isn't a pull, but really a canceled push, and at the very stability of our human-scale world is just a beautiful, delicate balance point in a cosmic tug-of-war. What do you think?